Hi, I'm Halim, and I'm from Heritage Woods. This is my science fair project. It's a Portman Bridge cable sweeper. And what it's meant to do is replace the current solution of sliding chains down manually on the bridge. This is a motorized solution, so that way it sort of eliminates the potential risk to BC workers. It's taken roughly maybe 120 hours-ish of 3D printing, as 3D printing is a rather long process. I'd love to be able to afford a higher end one, which would really bring down that print time. In terms of learning how to 3D design as well as the physics behind it, it took me a lot longer. It's sort of an ongoing study I've been doing, and yeah, this is my project.
Hi, my name is Angela Yu, and I'm from Heritage Woods Secondary School, and I'm currently a grade 11 student. And my project's on the Mpemba effect, and it is when hot water freezes faster than cold water, but I have experimented with vinegar, which is very similar to water. The three types of vinegar I have tested with was the cold one, as well as the room temperature one as the hot one. And I had 5 trials in total because more trials the better. So my question was, does the Mpemba effect work with vinegar, which has a lower molarity? And my hypothesis was yes, molarity will have no effect towards the Mpemba effect, and therefore Mpemba effect will work on vinegar. And according to my results, after the 5 trials, it has been proven that my hypothesis is accepted, and this connects to the current world situation of global warming as well as acid rain and air pollution, because global warming results in the temperature rise in raindrops, and vinegar represents the future level of acidity in acid rain. That's it. Thank you.
Hi, my name is Chen Shao, and this is Yifan Zhao. And we come from Centennial. Even though it looks like leaves, it's actually a copper. And copper is a kind of metal which has a characteristic reddish color, and it's electroconductor. And our inspiration comes from last year. We were doing the international crystal growing competition, and we use a chemical called copper sulfate, which will grow the crystal like this.
So in our experiment, we used different conditions like concentration of the copper sulfate solution, the shape of zinc metal, the number of zinc metal pieces, wire, magnet marker to alter the formation of copper dendrite. So by altering the formation of copper dendrite and actually to limit or restrict the copper dendrite growth, we can actually apply these factors to battery industry, and battery industry can use it to better the battery's lifespan and like different effectiveness of batteries, because like very recently we just found that metal dendrite is the cause of many battery explosions, and we think by doing that we can have many applications of this experiment, and it will have a very positive effect.
Hi everyone, my name is Nirvon Shoa. I'm a student right now at Heritage Woods Secondary, and you might have seen my interview earlier, and this was the app that I've created. It's called Mint Browser, and it's a revolutionary, secure mobile web browser. As a web browser, Mint Browser is designed to put everything on the main screen. For example, swipe from the right, you can jot down notes. This is perfect for the student who wants to take notes at school. And the best thing with Mint Browser is that they are synced with cryptography, so you don't have to worry about anyone, in a sense, sneaking on you or taking a peek at what you're doing, because it's all confidential and has the best security available. It even has a fingerprint scanner. Bam, that easy. Now this is the incognito mode. You can swipe from here to view your private bookmarks and history. Swipe from here to view your private notes. And guess what? It's all encrypted. It's all safe, and it's all easy to use.
Hello, I'm Winfield Chen, and I'm from Centennial Secondary School. Today, you're going to be looking at some glycerol-based biopolymers. And so the pitch behind this is that I made some new plastic materials out of renewable resources. vegetable oil. And so basically, the whole thing behind vegetable oil is it's a renewable resource, and currently right now, plastics are made from petroleum products, which are not renewable and bad for the environment. So this is what I made here. This material here, it doesn't look too fancy, but it's quite a wonder material. One side of it is not sticky. It's kind of, it's got a lot of air pockets in it. It's foamy, it's squishy. You'll like to touch it. The other side is sticky. It's adhesive. It's just like tape or glue, and this is an application of it. And so what I can do is I can just stick this right onto my poster board, like so. And it'll stay on the poster board because it's adhesive. And so this new plastic from vegetable oil is actually derived from something called glycerol, which right now is a waste product of biodiesel production. People just throw it away. And so what's so neat about this is we're taking these waste products and we're making cool things out of it. New plastics, you can make plastic bags, adhesives, medical applications, so much potential in this.
My name is Bardia.
I'm Jasper. We're from Port Moody Secondary.
Our project shows the electrolytes in different drinks by measuring the current in order to find out which drinks have the most electrolytes. So sport drinks always advertise that they have the most electrolytes and that they are the best for replenishing your body. But our experiment contradicts that claim because we found out that coconut water actually has more electrolytes than sport drinks such as Gatorade. Jasper will explain why electrolytes are important to performance.
So basically, electrolytes are important for athletes because electrolytes, they're different salts and chemicals that have an electric charge. When you exercise, you lose electrolytes, and you need to get the electrolytes back. 'Cause if you don't, your muscles will get cramped, and you'll also pull your muscles too.
So both me and Jasper play basketball on our school team, and our coach always insists that we bring Gatorade with us so that we can replenish our electrolytes during games. But now we found out coconut water is actually better than Gatorade in terms of electrolytes. We can tell our coach maybe that me and Jasper can bring coconut water instead.
I'm Iris from Port Moody Secondary.
And I'm Albert, and I'm also from Port Moody Secondary School. And so in our project, we chose to do our experiment on acid rain. So we measured the effect of acid rain on the health of plants. And we conducted this through 2 experiments. And in both experiments, we found that acid rain severely damages our plants. And in both experiments, our plants with acid rain, which we modified with vinegar, both died after only 2 to 5 days. In our second experiment, we used moss and we added different levels of vinegar, and in here we found that those with more vinegar had significantly died, and the moss itself has dried and it's very easy to pull apart, whereas those with normal water is very strong and sturdy. And so through this experiment, we wanted to raise awareness of how severe acid rain and how negative it is to our environment. And so we hope that through conducting this experiment, many people will be more aware of our experiment, and we hope that we will reduce acid rain through not driving and reducing acid rain.
We want to make sure that everybody recycles, reduces, and reuses. And we want to make sure that people know that driving also affects our environment. We want to reduce the amount of fuel that we burn.
Hi, I'm Maddie from Port Moody Secondary School.
And I'm Rebecca, and I'm also from Port Moody Secondary School. So basically, with this winter, we noticed that there was a lot of snow and ice, and with snow and ice comes a lot of salt on the roads. And when the snow leaves, the rain comes, and it washes away the salt into our ecosystems. So really what we wanted to do was we just wanted to test the effects of salt on our ecosystems and on native plants.
So what we did to begin is we bought 6 plants and separated them into 3 groups. They all got water every other day, the same amount of water. With this group, we added no salt to their water source. With the second group, we added 5 milliliters, and the third group 10 milliliters, to test how different amounts of salt affected different plants. Within 2 days, the group with the most amount of salt died. Within 5 days, the group with the minimal amount of salt died, and the group with no salt showed signs of growing. This is because in rock salt there's sodium and chlorine, both which have negative effects on plants. The sodium It blocks the nutrient roots, so it blocks magnesium and potassium, which are in charge for producing chlorophyll, so the plant could not grow.
And really with this project, we just wanted to make it significant and relevant to our communities. So for example, we went to the Port Moody Works Yard and we asked them for their road salt that they use on our roads and our streets, and we used that in our experiment on these plants. And then we collected local rainwater and we collected soil, and obviously we researched native plants of BC just to make sure that it was relevant. And we think this is really important for our community, not only for plants, but if rock salt has this much of an effect on our plants, we think that obviously it needs to be researched more on animals. For example, I was talking to a man who runs a hatchery and he thinks that it's negatively affecting his fish. So really with this project, we just want to point out its problems and how it harms our ecosystems.
We also think our project is significant because for areas who receive a lot of snow, say Winnipeg or up north, with a lot of snow, once again, comes salt. They must put a lot of salt into their streets, which gets washed away into their forests.
So hi, my name is Anita, and my project is about acids and bases. So acids are mostly sour, but not all of them are actually edible. For bases, most of them are bitter, but not all of them are edible. So here, I put 2 warning signs just for you to see that you shouldn't eat every single one or touch them or smell them because they could be dangerous, harmful, poisonous, or even deadly. So this is a pH scale. It's also called potential hydrogen. So it's between 0 and 14, and you can see that 7 is neutral. So I took some basic ingredients that we sort of seen into our whole life, like milk, orange juice, vinegar, lemon juice, and battery acid. So we took the extract by boiling it and putting a little water in it and just taking it. Here, it says bases. Bases from hydroxide ions and water. So it's OH minus. But then we want, if OH minus wants to take H plus and H plus wants to take OH minus. When they're together, they make H2O and the H2O evaporates. So right now, if we put them together, you can see little bubbles. But it doesn't make a lot.
My name's Austin Liu.
And my name is Jerome.
And we're both from Maple Creek Middle School. And our project, it's about boredom and the perception of time. So what it is it's about how our brains perceive time when we're bored.
And so this would be the case, for example, in math class at school. Let's say you really dislike the topic, and so you want this to be over with as soon as possible. And so there's 25 minutes before lunch, and so you're trying to stay through the class as quickly as possible, and so you think it's been 25 minutes, but it's actually only been 5 minutes, and that's just your brain overshooting the time or over-calculating how much time has actually passed because you dislike the subject.
So what we did is we have 3 test subjects, and we put them in an isolation room for what they think is an hour. So whenever they believe that it's been an hour, they tap out, and we see how their brain perceived the speed of time.
And we did 4 different tests of this for the subjects to see their brain performance before and after going into the room. And so we found a decrease in reaction time and verbal memory for all of the subjects, which was very interesting. And we think the reaction time, why it decreased, was because while you're in the room, you don't really react with your environment. It's just you consciously sitting in a room thinking about how much time has passed and stuff like that.
Hello, my name is Faith.
And my name is Asia, and we're from Moody Middle.
So for our project for the Science Expo, we decided to create an app.
This app includes a list of 70 plus diseases, which include symptoms and causes of each disease.
Our project is named Medpedia because a huge part of it, as Asia said earlier, is an encyclopedia of 70 plus diseases.
We dubbed it Medpedia because it's sort of like a mix of a medical journal and an encyclopedia.
Which is exactly what our project is. So in our project, we looked at seeing if people would actually use our app, because that's important, people using our app. We also looked at if people would think our app is creative, and if we could educate people and maybe stop the number of people dying from these diseases they're not even aware they have each year.
Yes, what sparked this idea actually was our passion for all of those people that go undiagnosed and suffer and are affected from it daily. People even die from diseases that they weren't aware that they had.
Our app took roughly 2 months to create. The first month was spent planning it, and the second month was spent actually creating it. Our app was created on an app called Apper, a free app we found online that will allow you to create any app looking professionally.
Yes, thank you.
Thank you.
Okay, hi, my name is Ben Holmes. This is my partner,
Gregory Scott, and we're here from Millard Middle to show you our project.
Our project is named the Scary Act. It originated after Grant Thompson, known as the King of Random, who is very well known on YouTube.
So, our project allows us to regulate how much power any appliance is receiving.
So in our case, we are using a common household drill, which we can regulate to go as slow or as fast as we want.
The way the project works is that in our water we have sodium hydroxide, which allows the water to become more conductive. When the two electrodes are in the water, the electricity passes through the water, but as it passes through, it loses integrity. The closer the electrodes are to each other, the less distance it travels, and the stronger the electric current is.
Hi, my name is Sofija and I'm from Traditional Learning Academy. And the project that I did was how much lipstick or lip balm you eat in a year and is it harmful? So what I did was I bought lipsticks and lip balms and I wrote down the ingredients and I looked up at the ingredients at the EWG Skin Deep database. You write down the ingredients and it's going to give you the function, the risk rating, and the risks. So what I did was I weighed the lipsticks, I put it on and I wiped it off and I weighed it again and did it that 3 more times. I had 3 other testers do it too and I averaged up the total and the average amount is 11.6 milligrams. A 12-year-old who weighs 50 kilograms would have to eat about 32,500 milligrams of BHT to be harmful, which is about 1,000 lipsticks a day. And it's impossible to eat 1,000 lipsticks a day because you'd get sick in the meantime, and also because you'd have to pay a lot of money to get the 1,000 lipsticks.
Hi, my name is Joshua. And I'm Neo. For our project, we are experimenting on beverages and the tooth. Our research question was, what effects does sugar have on tooth decay? Our hypothesis was that if there is more sugar on the tooth, then there is a faster growth of tooth decay.
So we decided to test out for 2 weeks what would happen to the teeth as they were exposed to the beverages. So we got 3 bleached teeth from all different sources, and we tested it out for 2 weeks. And this is what happened. We think that sugar and acid contents within the beverages were the main cause for what you see here. What we used, tooth 1 was exposed to hazelnut coffee. Tooth 2 was exposed to Osis Premium Juice from no concentrate and with pulp. And this was exposed to Coca-Cola. And what we learned from this experiment is that don't drink too much Coca-Cola, brush your teeth and floss, and also just be careful with what you drink, because anything that you consume can affect your teeth one way or another.
Hi, my name is Danilo and I'm from Heritage Woods Secondary School, and my project here is on teaching beginners how to code. Now this project is meant for kids in an elementary school, usually around grade 2 or 3, but it's also meant for older people also, just people in general who are beginners to coding and don't really know where to start. Now, what I did is I researched child psychology, and I discovered that children, when they're shown a very difficult task or something that's very confusing to them or complicated, they're very shut off to the whole idea, and they sometimes just decide not to learn it or go through with it. So what I did is I made a program which has a programming language which is a lot like English. So comparing that to other programming languages which are very complex and difficult, the one that I made, which looks a lot like English and just normal writing, it's very easy to understand and comprehend and kids can definitely learn it very, very quickly. And I'm sure that one day I can see this project definitely going into the education system, as there's not much for elementary schools to learn about coding and to encourage kids. So my project it's intended to be a foundation or a base of computer science for children and beginners and just anybody looking to get into computer science.
Okay, my name's Brogan.
And my name's Monica, and we're with Port Moody Secondary School. So for our project, we wanted to find out why certain fruits, such as apples and pears, oxidize, and what would be the best way to prevent that. We learned that when you cut an apple in half, certain enzymes are released, which then mix with the phenolic compounds to produce another chemical that turns brown when it reacts with oxygen. This is almost like a rust on the outside of the apple. So we originally thought that lemon juice would work the best because it's very high in citric acid, which is a natural antioxidant in fruits such as oranges, but our results did not show that.
So for our experiment, we took a part water and part antioxidants such as salt or ginger ale, and we left the apple slice sitting in the ginger ale or mixture for 3 hours, and we found that salt and ginger ale worked the best. Although salt looked more edible, it changed the taste a lot, and when we tried the ginger ale, it still tasted fresh, like it had just been cut, even though it was 3 hours later. For our hypothesis, we thought lemon mixture would work the best because it's so high in acidity, but when we mixed it with the water, it diluted it so much that it was one of the least effective antioxidants.
Hi, my name is Humer and I'm from Pine Tree Secondary. So this is an electromagnetic wave alarm. It's an invention I've made. It's pretty much just an alarm that works in a unique way. So how it works is that when I turn this on, light from the laser bounces from that mirror to this mirror to that mirror and then to the sensor. And what it does is that it detects change in light. So as long as the light from the laser is on the sensor, nothing happens. But when the light is cut or blocked, the sensor receives it and the buzzer turns on. So that's the alarm part of it. If I cut the beam, you hear a buzzing sound. I could turn it on. And right now, if I walk here, this is supposed to be representing the room. If I walk here, this will turn on. This turns on. That's the alarm. And then I could remove the key here to stop it from working, or use this remote to turn it off.
Hi, my name is Sydney and I'm from Moody Middle School. I did my project on bending water with static electricity. So basically I used 3 different liquids and 3 different balloons. The balloons were 3 different sizes, 1 big, 1 medium, and 1 small. The 3 liquids I used was milk, water, and Coke. With milk, it benched the most out of the 3. And if I used the biggest balloon, it would bend more than if I used the smallest balloon. With water and with the Coke, it actually didn't bend at all, because when the water, the molecule looks like this, and when you bring the negatively charged balloon near the water, the 2 electrons are attracted to the negatively charged balloon, and when you bring the negatively charged balloon near the water molecule will actually turn towards the negatively charged balloon, and that's what causes the water to bend.
I'm Himasha. I'm from Port Moody Secondary School, and my project is the thermoelectric toothbrush. This is a toothbrush that can reduce pollution, that could improve an average person's health, and it's actually very beneficial. It reduces the risk of cancer, gum disease, diabetes, and cardiovascular disease. Also, the United States alone produces up to 1 billion toothbrushes per year, which go to waste, and that's a lot of plastic that takes to decompose. However, the thermoelectric toothbrush is a more eco-friendly version. So this basically means that the thermoelectric toothbrush uses a Peltier tile. So when one side of the tile is heated and one side is cooled, it produces up to 12 volts of energy, unlike batteries, which only produce 1.5. So this is way more efficient, considering you don't have to buy new batteries all the time. All you have to do is hold the toothbrush, and any human produces about 100 watts of energy. So the heat from your palm would power the toothbrush, and that's it.
Hi, I'm Kate.
And I'm Madeline.
And we're from Hillcrest Middle School. Okay, so let's just say you're at work or at the mall or at school, and there are 4 recycling bins in front of you, and you have an object, let's say a water bottle, and you don't know which bin it goes into. So if you move over here, this is a mini computer called a Raspberry Pi, and on top of it there's a camera. If you put the water bottle in front of the camera
and click the button Scan Object, it'll take a real-time photo, allowing me time to adjust the object, and then it'll take the picture. So now it has the picture. It's going to process the image and determine what the image is of and which bin that object goes into. So now it has the object name and the bin name. It's going to light up an LED, like here, and
it will also say it on the screen.
Hi, my name is Joyce from Hillcrest Middle School. So my project is about ocean acidification and how it affects marine life. So ocean acidification is a byproduct of climate change. So when carbon dioxide is released into the atmosphere, some of it goes into global warming, and some of it is actually dissolved into the oceans, and the oceans convert that carbon dioxide into acid. And I explored how that acid affects shellfish and what it would be like in 100 to 500 years from now. In my control jar, which was just regular seawater, the shells remained relatively the same. In my slightly acidic seawater, which is predicted to happen in about 100 years from now, I noticed some bleaching at the edge of this manila clam, and also the protective covering was lost in this varnish clam here. And in the very acidic seawater, which is predicted in about 500 years from now, I noticed major bleaching in the manila clam. This varnish clam's protective covering is almost all lost.
I'm Aisha, and I'm from Coquitlam Middle School, and this is my project. For my project, I did it on radiation-powered spaceships, and basically during the 1950s there was this idea to power spaceships by exploding nuclear bombs behind a spaceship, propelling it through space. It was cancelled because it was dangerous. My idea was to make it safer. And basically, my form of radiation is decayed uranium, because uranium by itself has unstable isotopes, which makes it radioactive. And when it is depleted, it becomes more radioactive. So basically, how it will work is there would be a trigger in the controls, which would basically set off a conventional explosion in the starter. And it would go through hollow decayed uranium, which would make the conventional explosion radioactive. And radiation, it basically spreads extremely fast, which would increase the velocity. And when it would hit the top mechanism would spin counterclockwise in a spiral, going forward and launching it into space.
My name is Iris. I'm Ella, and we're from Maple Creek Middle. Okay, so we did our project on why milk is not a significant source of calcium. So for our experiment, for 15 days, we put an egg in 1 cup of milk for 10 days. At the end of these 15 days, we dropped a milk egg and a regular egg from a 1 meter distance. The result was that the milk egg actually broke more than the regular egg, so that kind of proves that milk is not really a good source of calcium. Milk has a really strong acid that takes the strength from your bones, and it actually increases the number of fractures you can get, and you have a higher risk of breaking your bones.
Hi, my name is Chelsea. I go to Coquitlam Middle School, and my project is called Violin String Swap. So what my big question is can the violin E string be replaced with another string material and still sound the same? So the 3 strings I used was copper wire, elastic string, and fishing line. My hypothesis was that the fishing line would work the best because a guitar string and a violin string are under about the same amount of pressure, and so and on a classical guitar there's a string that looks quite similar to the fishing line, so that's why I thought that it would work. But it turns out after all the experimenting that my hypothesis was wrong and that the copper wire worked the best, because a general violin string is actually made of sterling silver, and copper wire and sterling silver are about the same material.
My name is Hannah. And my name is Samuel. We are both from Self-Design. Our project is about acid rain. At the beginning, as we see here, it forms by nitrogen oxide gas, so it equals like gas by cars, and sulfur dioxide gas, and gas by factories. The trees, they're looking dead. It's because of the acid rain. The houses here they don't look nice to go and live, right? You would have to repair each time. That's what happens to acid rain with houses. Here is a good place. So then, if you want to prevent acid rain, there's a way you could prevent it. Instead of using a gas-powered car, you could use an electric car, a SkyTrain, a bicycle, a scooter, and other ways, such as like an electric bus, and others. I'm very glad you heard us, and thank you very much. Goodbye. Bye-bye. Hello, my name is Emily, and I'll be showing you my experiment. My experiment is about demonstrating macroscopic effects of quantum mechanics using polarized light. In my experiment, I want to show you some evidence of quantum mechanics. I will show you that classical mechanics don't work as well as quantum mechanics. You use vectors to describe the light in classical mechanics. Vectors is like going diagonal is the same thing as going horizontal and then vertical. In quantum mechanics, you treat the light as a photon instead of a wave. Since now we could change the polarity of our passing photons with the first polarizer in our setup, some of those photons can now pass the final polarizer and be detected by our camera. So Albert Einstein didn't like quantum mechanics because he thought everything in nature was exact, but it actually is random when it gets really, really small. Thank you. Hello everybody. Hi, my name is Angie. I'm from grade 5 and I'm from Central Elementary. Hi, my name is Carolyn. I'm also from Central Elementary, also from grade 5. Today we will be explaining and doing some fun explaining about the 5 senses. The reason why we picked the 5 senses to do our project on is because we thought that people took the 5 senses for granted in their daily lives way too often. Did you know that the most common eye color in the world is brown? Also, your eye moves about 80 times a second. When you hear a noise, you will hear that it involves sound waves that go down your ear and into your ear canal to your brain. Sound waves are known as air vibrations as well. Taste involves your tongue. Your tongue is split into different categories that explain bitter, sweet, sour, and salty. Each sense has its own part of its brain, and they're connected by thousands of nerves. Thank you for listening to our presentation, and we hope you enjoyed and learned something new about the 5 senses. Thank you. Hi, I'm Rian. I go to Kilmer Elementary School, and my project is Girls Rule, Boys Drool, literally. And I did a dog IQ test for these 4 dogs, 2 girls and 2 boys. My dog Jeppy, that's Daisy, that's Ruxin, and that's Jimmy. They live in our complex. So I tested them with these 4 tests. So this is my graph of the progress, and the girls are the green. So this is a cup memory test, and the girls beat them by a lot, the boys by the lot. This is the treat reacher, and the boys and the girls tied. And this is the treat under the towel, and the girls beat them but not by much. And for the blanket test, the boys beat the girls.
I'm Stefan from Traditional Learning Academy, and my project is about my shoes untying. So a few weeks ago, some science scientists from the UC Berkeley Mechanical Engineering found out how shoes untied. First, the impact of your step loosens the knot. Next, the swinging of your shoelaces unties it. I both want to test their theory and make my shoes stop untying. The first thing which I tried was tape. It was supposed to hold down the knot, but it was just hiding it, and the impact of the step loosened it, as the graph shows here. The control means the one with no modification, and the experimental one means the one with one of those 3 modifications. Second, I did magnets. When there's a lot of impact, it comes apart, and when there's a really hard impact, these come off, and extra weight makes more swinging. Last, I tried Velcro. It worked really well. It works so well that it's even hard to take on and off. And what I found out about it is that Velcro works a lot better than anything else, and that they were wrong. The impact is what really makes the difference.